Assalamualaikum dan selamat sejahtera. Example solution process. Ch02 kinematic of linear motion. Example 2.1 linear motion. A tow train moves slowly along a straight track according to the displacement s against time t graph in figure below. Y-axis for displacement unit centimeter and x-axis for time unit second. Question asks A. Determine the average velocity for the whole journey from time 0 second to 14 second. Question number B. Calculate the instantaneous velocity at time equal 12 second. Now, determine the average velocity for the whole journey from time 0 second to 14 second. We use equation average velocity S2 minus S1 T2 minus T1. Substitute value S2 10 cm, S1 0 cm, T2 14 second, T1 0 second, and then we get answer 0.71 centimeter per second. Now question B. Calculate the instantaneous velocity at t equal 12 second. From time 10 second to 40 second, velocity is constant. Therefore, velocity at time 10 second equal velocity at time 12 second and equal velocity at 14 second. Now, we must calculate gradient graph from time 10 second to 14 second. We use displacement 10 centimeter, final displacement and initial displacement 4 centimeter. We use equation for instantaneous velocity. We use equation gradient V equal 10 minus 4 divide 14 minus 10. We get 1.5 centimeter per second. Example 2.2. A velocity time graph in figure below shows the motion of a leaf. This graph shows y-axis represents velocity unit meter per second and x-axis represents time unit second. Question asks, determine the total distance by the leaf from 0 second to 25 second. And question B, calculate the average acceleration between 0 second to 5 second. Now, question number A, determine the total distance by the leaf from 0 second to 25 second. From this graph, total distance equal area under the graph. We have three areas under the graph: area A1, area A2, and area A3. Total three area A1 plus A2 plus A3. We calculate area A1 1/2 multiply 2 and then multiply 5. Area A2 1/2 multiply 2 plus 4 multiply 10, and area 3 1/2 multiply 5 plus 5 plus 10 multiply 4. And then we calculate, we get total distance 65 meter. Now, question B, calculate the average acceleration between 0 second to 5 second. We use equation average acceleration V2 minus V1 over T2 minus T1. Substitute value V2 2, V1 0, T2 5, T1 0. We get answer 0.4 meter per second squared. Now, example 2.3. The driver of a pickup truck going initial velocity 27.78 meter per second. Apply the brake, giving the truck a uniform deceleration of 6.5 meter per second squared. Sign negative because deceleration. Will it travel distance 20 meter? Question A. What is the speed? What is the speed of the truck at the end? So, speed is final speed, symbol V, of this distance 20 meter. Question B. How much time has elapsed? Now, question A. What is the speed of the truck at the end of this distance? Distance 20 meter. Given information, acceleration negative 6.5 meter per second squared, distance 20 meter, initial velocity 27.78 meter per second. Now, we use equation V squared equal U squared plus 2AS. And then substitute value, initial velocity 27 0.78 squared plus 2 multiply acceleration negative 6.5. You must insert negative and then multiply 20 meter. And then we calculate, we get answer 22.62 meter per second. Now question B, how much time has elapsed? We use equation V equal U plus AT. Substitute value V from question number A, 22.62, initial velocity 27.78 plus open bracket negative 6.5 close bracket multiply T, and then we get T 0.79 second. Now example 2.4, a student draw a ball from the top of tall building. It takes time 2.8 seconds for the ball to reach the ground. We'll consider when a student draw a ball, initial velocity 0 meter per second. Question A, what was the ball speed or final speed just before hitting the ground? Question B, what is the height of the building? Question A, what was the ball speed just before hitting the ground? Speed, we consider final speed. Given information, initial velocity 0 meter per second because ball drop, time 2.8 second. We use equation V equal U minus GT. Substitute initial velocity 0, acceleration due to gravity 9.81, time 2.8, and then we get final velocity or speed negative 27.47 meter per second. Negative sign because direction of the ball downward direction. Now question B, what is the height of the building? We use equation S equal UT minus half GT squared. Substitute U multiply T, we get 0, U 0 multiply T minus half G 9.81 time 2.8 second, and then we calculate, we get height negative 38.46 meter. Negative sign because displacement is downward. Now example 2.5. Figure below show a ball thrown by athlete with an initial speed u 200 meter per second and make an angle 60 degree to the horizontal. Question asks, calculate A, the time taken for the ball reach the maximum height. Question B, the maximum height. Question C, the horizontal range. Symbol capital R. Question D, the magnitude and direction of its velocity when the ball reaches the ground at point P. We look figure symbol initial velocity u, maximum height capital H, horizontal range capital R, point P, final velocity x component, final velocity y component, final velocity. Now question number A, the time taken for the ball reach the maximum height. Given the component of initial velocity us 100 meter per second, component y initial velocity 173 meter per second, we know that at maximum height, velocity for component y equal 0. Now we use equation Vy equal Uy minus Gt. Substitute Vy equals 0, Uy 173, G 9.81. Now we get value T 17.6 second. Now question B, the maximum height symbol capital H or displacement for component Y as Y given Uy 173 meter per second. Now we use equation Sy equal Uyt minus half Gt squared. Substitute Uy 173 multiply time 70.6 minus half multiply G 9.81 multiply time square 70.6, and then we get answer 1525 meter. Now question C, the horizontal range flight time equal 2 times the time taken to reach the maximum height. The time taken to reach the maximum height, we get answer from question A. Therefore, we calculate flight time T equal to multiply 17.6. We get flight time 35.2 seconds. After that, we calculate horizontal range R equal U at T. U at 100, flight time T 35.2, we get horizontal range 3,520 meter. Now question number D, calculate the magnitude and direction of its velocity when the ball reaches the ground at point P. Given U at 100 meter per second, Uy 173 meter per second. Given diagram, at point P, we have two component velocity. Velocity at component Y, V1Y. Velocity at component X, V1X. Before we calculate V1, you must calculate V1Y. Equal Uy minus GT. Uy 173 multiply 35.2, we get V1Y negative 172 meter per second. And then we calculate V1X. V1X equal Ux equal 100 meter per second. Now we calculate V1. We use equation Pythagoras theorem. V1x squared plus V1y squared. Substitute value 100 squared plus negative 172 squared. We get V1 200 meter per second. After that, we calculate direction. Tangent theta V1y over V1x theta, substitute value V1 negative 172 divide 100, we get theta and direction negative 60 degree. Example 2.6. A transport plane traveling at a constant velocity 50 meter per second at an altitude 300 meter release a parcel when directly above a point X on level ground. Calculate A. The flight time of the parcel. Number B. The velocity of impact of the parcel. C. the distance from X to the point of impact. We know that altitude 300 meter is negative value because displacement below reference point. Because displacement below reference point. Now, question number A, calculate the flight time of the parcel. We know that vertical displacement Sy equal negative 300 meter. Now, we use equation Sy equal Uyt minus half gt squared. Substitute value 1 by 1, Sy negative 300, Uyt 0, negative half G 9.81, and then we get T 7.82 second. Now, question number B, calculate the velocity of impact of the parcel. Firstly, we must calculate Vx. Vx equal Ux equal 50 meter per second. Secondly, we calculate Vy. Vy equal Uy minus Gt. Uy equals 0, G 9.81, and then T 7.82. We get Vy negative 76.7 meter per second. After that, we calculate the velocity. We use equation Pythagoras theorem. V equals square root 2 Vx squared plus Vy squared. Substitute value 1 by 1. Vx 50 squared plus Vy negative 76.7 squared, and then we get V 91.6 meter per second. After that, we calculate direction. We calculate value. We get direction 56, negative 56.9 degree. Now question number C, calculate the distance from X to the point of impact. Distance symbol as X equal U as T. Substitute value U as 50, T 7.82. We get the distance 391 meter.